Welcome to this video on steam locomotives in Harz, exploring their history, technology, and heritage, from mining pumps to tourism. Our journey explores the steam locomotives in Harz, tracing their path from the mining pump technology to a modern tourist attraction. A steam locomotive uses steam as its power source, generated by burning coal. This steam drives the motor wheels, converting energy into mechanical movement. Historically, it was the first means of mechanical mass transport on land, used for transporting people and goods, and operating on public, industrial, and narrow-gauge mountain railways. The technology began with the mining pump, addressing the problem of flooded mines. The solution, the steam pump, was pioneered by Thomas Newcomen in 1712. His practical steam engine used water vapor to move a piston, operating the pump. Mining and coal were the cradle of the steam age. James Watt, a key figure in steam engine development, introduced important improvements, including the centrifugal governor. This mechanical device automatically regulated engine speed, reacting to rotational variations without human intervention, ensuring safe and stable steam usage. George Stephenson, a steam railway pioneer, designed the Rocket in 1829 for the Rainhill trials on the Liverpool-Manchester Railway. The goal was to find the best steam locomotive for regular operation. The Rocket introduced key technical innovations that became standard for later steam locomotives. These include the multi-tube boiler for a larger heating area, the blast pipe for better draft and more efficient combustion, and direct drive of the driving wheels for lower energy losses. The performance of the Rocket was revolutionary for the 1820s, achieving a maximum speed of 45 to 50 kilometers per hour and having a mass of approximately 4.3 tons. It used coal as fuel and featured a 022 axle arrangement. The Rocket won the Rainhill trials, proving that steam railways were safe, efficient, and profitable. It became a design model for steam railways and marked the beginning of the modern era of rail transport. Mineral coal formed millions of years ago from plant remains under pressure and heat. The process transforms peat into brown coal and then into bituminous coal. Coal content increases with depth and age, making it essential fuel for steam engines and industry. Mining technology evolved significantly from the 18th and 19th centuries. Initially relying on manual extraction, it later incorporated mechanical hammers, steam pumps for mine drainage, and the first mining railways for coal transport. This evolution led to greater availability and lower cost of raw material. Coal processing involves sorting by quality and caloric value, drying, and sometimes pre-sintering to produce coke. High-quality coal with a high caloric value was necessary to power locomotives and industrial machines. Comparing calorific value, coal, such as lignite and bituminous coal, is less energy-dense than crude oil. However, in the 19th century, coal was cheaper and more readily available than oil, making it the preferred fuel source. Key coal mining centers in the 19th century included Great Britain, Germany, the USA, and France and Belgium. These regions, with their vital coal reserves, propelled the development of steam railways and the manufacturing industry. Coal was the ideal fuel for locomotives due to its high calorific value, which produced powerful steam. It was also easy to transport and store in stations and wagons, and readily available across Europe and America in the 19th century. Without coal, steam locomotives could not operate efficiently. Steam locomotives enabled the rapid transport of coal from mines to cities and factories. This led to the development of dedicated railway lines for coal transport and efficient connections between mines, metalworks, and ports, significantly increasing the pace of industry. Steam locomotives were crucial to the Industrial Revolution, providing a stable energy source for factories and accelerating trade and urbanization. They connected coal and steam power, forming the engine of modern industry. In Harz, steam locomotives transported coal to ironworks and factories. The Harz region presented difficult terrain for railways, characterized by steep slopes, narrow valleys, and tight curves. The main challenge was building tracks and adapting steam locomotives to this mountainous environment, requiring special technical solutions. Technical adaptations included narrow-gauge locomotives, reinforced boilers and brakes, and special wheels or rack systems, like the ABT system, for better traction on steep slopes. These ensured safety and stability for freight and passenger transport in the mountains. The Harz narrow-gauge railways feature a network of over 140 kilometers, using steam locomotives since the 19th century until today. They transport both goods and tourists, serving as a living museum of steam rail transport. The Harz narrow gauge railways network covers over 140 kilometers, connecting the Harz region. It is divided into three main sections: the Harzquerbahn, Selkettlebahn, and Brockenbahn. The Harzquerbahn, or Harz Cross-Country Railway, is the main artery, connecting Wernigerode in the north to Nordhausen in the south, running for approximately 60 kilometers through varied landscapes. The Brocken Railway, a branch of the network, ascends to the summit of Mount Brocken, the highest peak in the Harz. It is considered one of the most beautiful and challenging mountain railway routes in Germany. The Selkettlebahn, or Selke Valley Railway, is the oldest and most picturesque section, winding through the Selke Valley. It is known for its narrow curves and is popular with tourists. The Harz narrow gauge railways, built between 1887 and 1899, served initially to transport coal, timber, and iron ore from mines to factories. Today, the network is primarily focused on tourist traffic and is a symbol of technical heritage. The Harz railway network is maintained using historical methods, ensuring the preservation of the steam locomotive tradition. This requires specialized knowledge of steam technology, coal combustion, and railway infrastructure maintenance. The preservation of the Harz narrow gauge railways ensures that the history of steam transport is kept alive for future generations. It is a unique example of technical heritage and a tourist attraction,